Hi, I'm Jian, and in this video we will talk about how to use the Moka Pot to make a good taste coffee. In the first part of the video, I will introduce my motivation and then we will go to theoretical analysis. Before the experiment, I did three useful trials. Some is for my safety, some is for the following connected law of theorems. So first I use a tea bag, but when I tried it, I forgot to close the cap. So I find the boiling water and steam is going out like a fountain. So give me a reminder, like for safety, please close the cap while using the port. And for the second trial, I did it into two parts. The first is I used the dry new grounded coffee and I waited for 2 minutes and 10 seconds. Then I heard a sound and also see some steams going out. I waited for 20 seconds when it's boiling and then I stop heating. I checked the boiler and then I find still left 25% volume compared with the initial one. Then the next day I used the grounded coffee for the second time and I find okay, although I waited for 2 minutes and 30 seconds, I still cannot get any coffee in the up chamber. So here it means I should use dry and new grounded coffee is also for my safety, and this one can connect with the Darcy law in the following analysis. And the third time, I have few experience. I use new grounded coffee, the water level under the safety valve, and close the cap while making around 2 minutes and 10 seconds for heating, and I always use the same flame size. And I ask myself, what should be changed? I think probably I should change the boiling time. So here, I still heat it for 2 minutes and 10 seconds, and I boil it for 1 minute. But what happened? I find for the up chamber, it looked like similar. No too much big change, and but for the boiler I find okay, there's no water left. So I thought for my safety I must control the heating time on the 1 minute. Then I decide to do the real experiment and do some analysis. I think about I need to check what kind of material I have. Now let me introduce my experimental setup for you. The first is once I hit the Moka Pot, I can use the endpoints of the two wires in it, like here, and then I can connect it with the Moka Pot, and then I use the max 31855 to detect the temperature. With some lines connected on the breadboard, I can use the nano to read the temperature data from the max 31855 and send the readings to the computer through a serial monitor. And by the USB, the wire, I can connect the computer, and our computer have some coding and packages. I can get the temperature simultaneously. Here is a list of the theories I used here, like the Erdogas law, the heat capacity, lighting heat, clauses, Capron, and actual is the Darcy law. I get the hint from the feedback, and also I consider the experimental uncertainty. Before the numerical analysis, I did a abstract physical modeling for it. Firstly, I measured the two diameter and also the height of the boiler, and I find it can be abstract into a cylinder. And I also noticed the safety valve and also the spot here because the height can connect with the gravity in the following analysis. And here I listed some basic calculation for this system. Here, I will show you my thought of improving my model step by step. Initially, I only considered the trapped air, so I used the ideal gas law. Then I have the absolute pressure, which is relative to the vacuum. Then I change it to the pressure of the gauge. And then I think about I should have a better model because the lower pressure is have two components. One is the pressure of the air, the other is the pressure of the vapor. So how can I find the pressure of the vapor? I should use the clauses equilibrium, and then I have the formula for the pressure of the vapor. Now we need to consider this more realistic model after extraction starts. The equation shows two competing efforts. Increasing temperature increases trapped air pressure, while increasing gas volume decreases trapped air pressure. As showed in previous graph, the water must be lifted upward through the height edge, and we also can connect it with the Darcy law because of the permeability of the ground coffee. The up part is simplified Darcy law, and from these formulas, we can find the final coffee flavor depends on temperature, flow rate, and extraction time. Too short an extraction time can under-extract the coffee. Too long an extraction time can lead to overheating, dryness in the lower chamber, and bitter flavor. As we have provided the measured geometric value and the volume calculation, here we will count the heating power. But there's also a limitation. This estimate ignores heat absorbed by the metal Moka pot and heat lost to the surroundings. Therefore, the power should be interpreted as an effective heating power into the water. Here is the pressure estimate of air and vapor. This is a simplified estimate. The real pressure depends on the leakage, non-uniform temperature, water movement, safety valve behavior, and whether the vapor space is saturated. For this calculation, only a small part of the pressure is needed to lift the water vertically. Most of the pressure difference is likely used to overcome flow resistance through the coffee grinds, filter, and the central tube. There are the last two parts of the numerical analysis. For this Moka pot, a reasonable predicted stopping time is 42 to 45 seconds. Well, there's still a limit. This is not a universal perfect coffee time. This is a physical-based first prediction for this Moka pot and this flame setting. For this Moka pot, I can say I already learned how to make a great coffee for myself. But furthermore, I want to know if I have a new Moka pot, like for any Moka pot, how can I do the general prediction for it? So from this project, I think I have the initial ability to have a physical abstract model from the particular equipment, and then I organize something for myself. So step 1, I can calculate the water volume from geometry, and step 2, estimate effective flame power from time to boiling. And then think about the step 3 should be estimated lower chamber pressure, and step 4 is to predict extraction flow rate. Finally, I have a general formula for required stop time like this. And in the end, I have some result like this. So now it's time to have a good coffee. Thanks for physics. I can drink coffee now.